All right, let's get going. So first off, thank you for heading back. We're in the final stretch. Nate, from the program direction after this, is it done or they're done in this room? But do we go back down for a final? Okay. I don't think we're going for that long. How long are we scheduled here? Out at 4:30. All right. So welcome back. I would like to just acknowledge where we all went together. And for those of you that are kind of coming in fresh, thank you. The first part of this session was really giving you a lot of context. There's a lot of blockchain context. There was a lot of Hyperledger context. There were great dialogue around from maintainers to consensus, right? So we covered a lot of ground, which should expedite this kind of bottom-up build. Okay, so that's what we want to do. Let's get into the platform, show, same thing as we did last time, just, hey, not sure I understand, help me, I'm thinking about this right now, guide me. Again, it's Kurt Wedgwood, IBM, Jonathan Levy, HACERA, Paige Krieger, learning, from IBM. And we've stayed focused on the Hyperledger fabric. What we were talked about earlier is the Hyperledger project has many different options, Indy, Sawtooth, etc. We've stayed narrow on the fabric. Fabric itself in deployments, right? You're at almost 5,000 transactions per second, right? Enterprise-based, permission-based, known. Right, and you've seen no Hyperledger. Jonathan kind of alluded to, right? Could there be native token in about 6 months? Right, where's it going? IBM in and of itself has connected through tokens with Stellar, right? So, and as I mentioned before, IBM will not go with their own coin, right? Just because we do not see ourselves as a financial institution, and legally we just won't take that risk. However, we are helping those companies that are looking at stable coins where it's really tied to a fiat. So just as a general direction, I didn't give that commentary before, thought I'd share that with you. I'm filling in right now for you, Mr. Jonathan.
So, okay, well, there are a few ways to go about it, actually. One, I just don't have a lot of time to run everything with you, and like few people here told me that they already run Mumbles. I want to be, what I want to do, like I spent like almost 2 hours talking about blockchains, how we got there, what are we doing, why are we doing, et cetera, et cetera. Now we have 2 ways to go about it. I think I can go step by step with like to set you up and running. So how many people here actually worked with Fabric before?
Has anybody worked with Fabric before?
Well, you run the Runverse one, so only one person? Okay, did you ever try, how many people here actually ever tried to work with any blockchain? Okay, what blockchains? What did you try? Ethereum?
Got Ethereum here.
Ethereum? Yeah. Okay.
We had Neo, a couple Neos, right?
Okay.
How about you? Ethereum.
So I'm wondering whether it's going to be useful for me to just go through some setup of Hyperledger Fabric Network. Everybody has a laptop here? Do you want to? Okay, so what I can quickly put together, if you give me a second, I will just give you the full lab to run on your own, on your laptop. And, okay. How do I send you guys a file? It's a good question, right?
I don't think you can.
I can't send you a file.
You have a Ripple page? Why is that funny?
Well, actually, I can.
Oh, so does he. Telegram, you'd have to know us.
Okay, easy. Go to HACERA.com/events. Boom. Give me 2 seconds. I'll just get it. HACERA.com/events, and I'm just going to add it to the page. And all the people that are here will have access to some very nice stuff. So if you go to, okay, yeah, let's just do this. I have a solution.
All right, does anybody want to take the throne? I've just heard from, what's your name? Alex says he's the worst dev in the room. Anybody else want to challenge him?
So if we go to
The world. All right. Paige, our advertising lead, is going to challenge you. But
can everybody go to this page? I've just uploaded something.
Did you go to HACERA.com?
If you go to HACERA.com/events, or go to HACERA.com and click here on events on the top menu. And then if you click on Blockchain Seattle, if you click on that green thing, you will get a full working version of 2 end-to-end labs with everything at your disposal. And then I'm going to go over it with you. Yeah? Nice. It's called being a hacker. It's a virtual box that has Fabric and the code that I'm going to go over so you have it at your disposal. It's actually an introduction to Fabric. So we have a lot of classes that we are selling. I'm just trying to teach you guys. So this, I think I'm going to cover at least 1 lab or 2.
The question, is it a large file? Sorry, Jonathan. Is it a large file?
Say again? It's a huge file.
It's a huge file?
Yeah. Is it too slow?
It just takes 4 hours to
Oh,
download.
really? You want to roam with my mobile phone? Oh, wow.
As long as it's 5G.
Is it 5G? No, it should be 5G. Really? No, it's 1G. Well, okay, so this image contains the full Fabric binaries with the ordering service, the Fabric CA, the SDK, the client, and the node. So everything is compiled for you. So look, I don't think, if you want to learn Fabric, I don't think you should take all the source and compile everything from scratch. We do it because we are developing it, and we test it, and we stress it, and we play with it. But the best way to go about Fabric, so there are 2 options, right? I can either go through this, or I can go to the Fabric Labs. So if we go to, let me just do it in real time. So we can also go through that if you like. I have no preference. Build your first network. It's a very nice example of how to run Fabric. So if you just Google build your first network.
All right, so we're typing in building your first network.
Mm-hmm. And because I'm downloading, I think the whole event is going to collapse. But, look, guys, I think it's more important for you to understand how the components talk to each other. That's the most challenging thing, and I'm here to help you with that. Like, just to download something and run it, I think is easy, but let's just do it. So, but by the way, this will also be slow. It's very difficult to do it without like a good internet connection, apparently. So this is the easiest. No, I think guys, sorry, our labs are much easier. Look, I think this is the best. So let's just go over this, okay? So let me talk about Fabric for a second, and then I want you to see it. So there are 2 options. Like, we can either download this stuff that it takes, like, I don't know why it takes 4 hours, but sorry, we don't have good internet for this.
But is this online that we could see while you're talking?
This is online. You can see while I'm talking, right? So this, yeah. So
What's our search to get here?
I think it will be just easier if I just go over this, because this is it's a self-paced class that we provided, but I don't mind sharing it with you. So, but I want to teach you how to work with Fabric, rather than you just try to do something for 30 minutes, okay? So the way we work with Fabric, everything works with Docker containers. So the idea was, remember that we have a distributed system with many components that we want to scale. So the first important thing that you have to understand, you have to download Docker images. So remember we talked about Hyperledger Fabric and we have the code. Our release procedure basically generates binaries that are Docker images that everybody can run on the Docker containers. This is why when IBM tells you, hey guys, it's like cloud agnostic, you can actually run it on different Docker containers. It doesn't have to be the IBM one or something that the HACERA set up. This is like a generic binary that everybody can download, okay? But I think the easiest way to look at it, so in this image that I gave you, We run everything in Vagrant. Maybe this is why it's low. It's just a little bit big. And we basically created the Fabric Fundamentals box, and once you load it, I don't think it's going to be difficult for me to run it, and I can just show it. But the first lab is just to run this, and then we set up the whole network. So what should we do? I can show you.
So would
this.
I be setting this up on a laptop? Do I need a server for this?
You don't need a server for this. So what's nice about this setup, the link that I shared with you on the website, is basically you download everything locally and you run a simulated environment. Because I'm running stuff in Docker, I can run a server and a client, and I can simulate a few nodes only in one machine. And they can have like a virtual IP, right? So what's nice about this, instead of me, yes, sorry.
Chow has a question. Sorry, Chow, we can't hear you.
Since we are using the Docker, why do we need the VirtualBox image?
You don't. This is just for the tutorial. It's just easy. So everybody runs exactly the same thing.
Oh,
so Docker you run in production. Like Docker you actually run for development, and we can all make sure that it's virtualized enough so everybody can run the same Docker. So we use Docker mostly for isolation. This is run in Vagrant because we wanted everybody to run on the same operating system. So everybody has the exact same input, outputs, and results. And maybe it's going to be easier if I just show you like the actual practical lab, whatever you guys prefer. I think it's going to be too much.
App. Yeah, let's go.
Yeah, it's going to be too much overhead now to set you up, etc., etc. But let me just tell you, right? So you have three main components. You have, as a customer or as a user, I'm always interacting with a blockchain through the basically SDK. So the client application or user application that is me, sitting, let's say, in a terminal or even with a web, and I interact using the SDK, and I'm going out to Fabric, and basically what I'm doing, I'm trying to interact with the blockchain, right? So I'm going to show you, actually I have the best recipe is probably going to be to, one second, I know what I need to do. We're going to do theory and practice at the same time. That's what we're going to do. So this is the advanced stuff that I didn't want to cover, but I just need one slide here, and that slide will make everything amazing. So do you remember that we talked about this before, right? So I have a client application that first goes to the membership services, obtains an enrollment certificate. This is how I get access to the system. And then with this enrollment certificate, once I'm kind of in, I can start proposing transactions to the network. I sign the transactions, and then I'm asking the ordering service to get my transaction into a block, because the ordering service is the component that is basically taking the transaction and packs them into a block, and then tells all the committers, hey guys, this is the next block, commit it to your local ledger. That's what we want to do, okay? So that's going to be our first network. And look, it's a bit complicated because it's a distributed system. That's normal. But I really want to cover like the key aspects that I think are really key for understanding how it works. So what we have here, let me just see what I can talk about that is not.
And I'm not clear. Are you able to then kind of go into a working system and show us the membership services, or what are you thinking?
I'm trying to think. Look, I have this image locally. I can just run the whole.
Yeah.
Should I do that?
Yeah.
Give me a second. I just need to see what I wanted to show you here. Because I can just show you the output here, and then I can go through more material. That's what I'm thinking. Okay.
And the output, what's the function that we're trying to show?
So basically, that's the step that people don't. So, okay, let's talk about the practical parts, right? So I have a working network, so I'm going to set up a channel. So the first thing to remember about Fabric, and I'm going to talk about the confusing parts first. Everything in Fabric actually works in a channel. So we always start with one, there's always a default channel. The reason for that is that we were able to basically create a peer-to-peer network. Let's say I have 20 participants. At the beginning, I can set up a channel where every participant is part of the channel. That's kind of the default channel. And when I configure this channel, I have to say who are the participants that are part of this channel. And in order for me to start to do that, I'm going to do something that's called config txgen. So basically, I'm going to have a configuration for this channel, and I'm going to set up a profile. And this is an example of how you run config txgen, and this is the profile. The profile is going to be for organization, one orderer, and we're going to create something called a Genesis block. And then I'm going to have channel block, which is this, and this is basically how I create the first ever kind of channel that has 4 organizations and 1 orderer. The reason I need to do it in Fabric is because I'm working with a permissioned blockchain. So I need to know the identity of all the participants that basically start this channel. Once I have this configuration, every one of these organizations will be able to set up a CA, and that CA can basically give us enrollment certificates for every participant. So you can think about it like a tree. So I have a root CA, which is that network. That root CA basically gets 4 different, let's call them Fabric CAs, but subordinates that are all part of the same root of trust. And then each of these 4, let's say, kind of subordinates is able to generate certificates for the organizations. So now I'm going to have 4 organizations with 1 ordering service. Remember, it's a service, not a server, so I can have like many kind of servers in this ordering service. But I'm going to have 1 root of trust, and it is for the network. The consortium agrees that we are going to generate 4 organizations. Each organization is able to bring in more participants to the network. Because we have this root of trust, I don't have a slide of PKI, but basically I can easily get a slide of PKI. Let me just show you how it looks. PKI.
So we've been setting up our network. We'd have a root certificate of authority. We have 4 orgs. What are we going to do with the 4 orgs?
One second.
We're going to write our first block. What's our block going to contain?
I want to show you this slide. Okay, so effectively, the way this is working, and that's kind of important in general. So I'm going to have a root certificate, which is here. That root certificate will give me an intermediate certificate, which is what each of the CAs are going to get. And then the end entity certificates. I'm oversimplifying, but this is going to be like your ECERT. Okay? It's actually nicer to do it like the other way around. So I'm going to have a root certificate. Let's call our, I don't know, what's a good name for our new blockchain? I think I had the name there. What was the name? Let's use the same one that we have here. So here we set up something called colleagues. So this is a colleagues network. So we're going to set up a colleagues channel, and we're going to have another channel that is going to be a party present. This is what we have in this example, okay? Now we start, okay, so Kurt was alluding to, I need to move on faster. So basically, I can have a config txgen with this profile, which is just a file. And then I can have another config txgen, so I configure another channel with this profile. And effectively, what we're going to get is, okay, I'm going to run the crypto txgen, and basically, now I'm going to have 4 organizations. org1 at HACERA, like this, org1, 2, 3, and 4. Once I've done that, I'm going to generate a Genesis block. That's key in any blockchain. Genesis block is the first block that we are going to start referring to when we add transactions. So it's really important to start from scratch. I'm really starting a full block. Imagine me starting Ethereum from day 1, and this is the first block ever with 4 parties, 1 orderer, and now we start transacting on a shared ledger, right? So I need to set up this Genesis block for the network. And, well, you're going to see an output like this. By the way, you can download and keep this stuff and run it on your own if you want. There's no problem. But effectively, basically, we're generating a Genesis block. We're writing the Genesis block, and then we set up the channel configuration. Why do I need the channel for configuration? So I don't know if it's easier for you to think like in terms of like Google forums or Slack channels or anything that has some segregations of users. Imagine, I don't know, is there anyone here that is not familiar with Slack? Slack, yes, no, no? Okay, yes? Okay. So in Slack, I always have a general channel, right? I have all the participants there. I can see everybody there. Maybe I don't know them. Maybe there are too many of them. But then I can always set up a private channel, okay? Now, I don't want you guys to think about Fabric channels as like Slack channels because it's nice intuitively. What is nice about Fabric channels is that we actually created a new blockchain. It's a completely new blockchain. So I took these 4 organizations and I set up a channel with the 4 of them. In this example, so our classes are pretty kind of hardcore, right? So example number 1, I already created another channel with 3 out of these 4, and I show people like in 2 seconds how they can work in tandem, right? So I have 20 participants. I have a channel for 4 organizations. I take 3 of them and I have another separate channel. What is nice about it, and it's important to understand, each of these channels start with its own Genesis block, and each of these channels has its own channel configuration. This is really, really key. No other blockchain will give you that, which is a good thing and a bad thing. But I think it's awesome if you need to do isolation. If you don't need to do isolation and you need to do everything in the public, okay, there are different blockchains that will give you that. But if you have, like this example, let's see if I finish the lab. It's more important for me that you understand it than for me to go for like quantity. I want quality. Like I'm just using the fact that I'm here. If you need to have an isolation of some stuff that I shouldn't share with anybody else, and in this example, what we have done, we agreed on a secret channel, what will be the party present, and then we set up a full voting application with a few proposals for a present, and then we surprise the 4th guy that is not in the channel based on what we kind of agreed in the voting that was private. This kind of funny example happens every day, all the time. It's true for payments, for validations, for confirming, from getting stuff out of, I don't know, like customs. Think about like anything that you see in supply chain that has state management. Not all the parties, A, need to know about everything, B, have to know, and 4, like sometimes they mustn't know. So that's one thing that I need to isolate. Second thing, sometimes I want to get a result from one channel and to use that outcome and to forget about all this information that I had in the channel and to use just the result of it somewhere else, okay? So this is another way of A, segregating, B, keeping what we call like the privacy preserving stuff that I can do some private transactions on the side. But number 3, which I think is really key, I don't have to have all the records everywhere. So it also allows you to scale. I can have 200,000 transactions, but only 5 are relevant for me, and this is why I'm on this channel. So maybe the general channel on Slack is going to be like so noisy, I don't care about that. All I care is about, okay, are we going to have dinner tonight or not? So that's another channel. Okay, so that's the mindset.
So playing that back, we've now set up channels for communication. We were going to put the Genesis block in. If I recall, we introduced channels between .6 and 1.0, is that correct?
Yes. Oh, so channels was a very big thing at one point. Oh, yeah, that's a very good point. So at the beginning, we started with no channels, and we said, okay, everything is public. And then we had the problems of privacy, regulations, segregations, and performance. And channels actually help you here. I wouldn't say that you should go do like too many transactions that are in channels because you have another, because actually there is some overhead, right? And we're very clear about that, right? You have to do a config TXGen, you have to set up a channel. And it's not something that you can like, you shouldn't start all the time like a new channel, close a channel, open a channel. But what we added actually after 1.0, immediately we say, oh, we love channels. We want to join a channel. We want to remove a guy from a channel. We want to be able to vote somebody out. We want to be able to tell somebody about the Genesis, right? And at the beginning it was nice. Okay, hey, channel, look, the regulator is now happy. I'm not sending this stuff. Like the stuff that is in China is in China, North America is in North America, the Canadian side is just in Canada. Everything is good. In, I don't know, 2 weeks from going to production, people came to us with like 25 use cases related to channels, and they wanted this, they wanted that. And we had to tell them, guys, this is not like Slack. It's not that easy. I don't have a centralized system. I don't have a server that everybody connects to. Like, it's difficult, right? So what we started adding at 1.1 and 1.2, and now actually it's going to get stronger in 1.3, is the ability to move data in a segregated way, but also to join a channel. And how do you do that? By the way, do you understand what's the problem? So let's say I join a network, and there are 4 organizations, and then there's a channel for 3, and now suddenly I want to join that channel. What's the problem? How do I join? So the main problem that I have, it's like me joining a network that is permissioned. how do they know about me? Okay, because it's permissioned, right? I'm not in the 4 organizations, I'm number 5, or I'm not in the 3, I'm number 4. Okay, so that's the first problem. Problem number 2, how do I validate that what's out there is true? Because look, if I'm late to a party, you can tell me anything that, I go to a party started at 6 p.m. I arrive at 10, say, oh, Jonathan, you have no idea what happened here. At 5 o'clock we had this, and at 6 o'clock we had that, and so. Okay, so I don't know, I don't have any ability to evaluate what happened, right? So there are 2 options. Either I come in from the Genesis block and reevaluate everything, or I trust somebody to say, look, so far so good, this is block number 17, I think it's fine. And then some people will kind of say, actually it's okay, we validated it. So I either validate everything on my own, or I have other people to vote for me, so it's kind of a delegated form. Again, different use cases, different businesses wanted different things. We kept the flexibility in.
But you can configure it both ways.
Yeah.
All right, so the big lesson learned is, ideally when you set up your network, set it up with your channels, know who's going to communicate what.
So now, and there's a lot of, you have to understand, like, to run these blockchains, there is a lot of kind of business applications and requirements and people that are managing it and SLAs, like service level agreements, right? So it's nice to do a blockchain, hey, let's just say something, or it's easy to play chess online. But if I'm playing chess on a blockchain and nobody can erase it and I'm going to get paid and I'm going to get downgraded, just think about you. If now chess.com will publish everything I had, and I'll be a little bit more careful about the stupid moves that I have, or not to play very late at night, and not to look stupid, right? So imagine now you do this, but with a business blockchain, where people like financial institutions, insurance, have reputation at stake, money in line, like shareholders. So people are a lot more careful, which is why it takes all of us a lot of time. It takes IBM time, it takes us time, it takes it's a slow moving process, but it's actually happening. And what we do, we just listen to what people want and try to, yeah? So next step. We got so now, another thing that is important, okay, so we generated the 4 certificates and we get the certificates for every organization. We're getting the Genesis block for the ordering service, and well, this is actually simple. This is just like normal outputs. But basically, we generated the colleagues channel configuration, and we have the party present channel configuration. Okay, these files, if you want, I can show you. It's a very simple configuration file. You can look at it. It's all .yaml, yet another markup language. Right? So it's very easily readable. All you need to say is what are the names of the participants, what are the names of the organizations. This is just strings. Like nobody cares about how you call your ordering service and how you call your organizations. That's very flexible, okay? What is nice about this, you don't need to touch the code. This is just configuration files, right? So that's another very big thing. If you want to change the configuration of Hyperledger Fabric, you change configuration files. You don't need, how many customers, how many people came to me and said, dude, I don't know, the developers are always debugging and compiling. I said, why do you need to do that? You have the code, you have the binary, there's like the executable that runs in a container. Please, all you need to do is change the configuration file. Don't add another lookup to because you're not going to be compliant. Like we had so many organizations over the years that work in a consortium, but they think that they have a better version of Fabric. I said, you cannot. You can't change your own node when we all have to run the same version, right? If I work on T-Mobile, I have to work with the same protocol with T-Mobile, right? So it's the same with Fabric. Change your configuration. Don't change your code and debug and have something proprietary that will later on not scale. I'm not saying that you always have to work with the latest version, but work with something that is compliant, that people can just download. And it doesn't matter if you work with Oracle, IBM, it doesn't matter. It's not about the vendor, it's about the mindset. Let's agree on the protocol and the layer that we are going to work with, so that we all run the same thing. We can change configurations, we can change private keys, we can change certificates. Don't change the code. You want to change the code, come to us on the development side, propose a feature. That's a different story. But not in production when you run stuff with real data, okay? So, yeah.
Hey, Jonathan, what role would somebody have if they were changing the config? What is that?
So, you mean how people actually deploy this stuff?
No, I'm just saying, is it an architect? Inside the organization.
That's a very good question. Okay, so It's like, blockchain is moving so fast. I always say, like, I count like how much time I spent in blockchain in kind of blockchain years. It's like 7 years for every year. So 2016, the people that talked about blockchains were everybody thought they are crazy. They're like, oh, you try to do Bitcoin, why are you doing so much on blockchain? And it was usually the innovation. It was the innovation teams. They all tried to have a prototype, propose to management. It started like this. 2017, what we saw, it became more like the CIO kind of guy that is trying to have a mandate. Let me look at blockchain, let me look. And it's kind of like, I don't know, look, I wasn't there when, I was an investment banker on a trading desk when kind of the mobile banking for retail came through. So I was not on that kind of arm. But it feels like, I imagine it was very similar. The CIOs trying to think, look, we are trying to collaborate with so many people. Why do we have duplicate systems? So many CIOs starting to talk business to other people. And there are a few advisories, IBM Global Business Services, very big players that actually drove that change. Like, I think the big thing really was from Fabric 1.0 that we released in July. And then it became the data officers, it became the system architects, it became the IT, of course with innovation. But what I see now in 2018, it's more the business side person. It's less the CIO. They already have the mandate. They already have the budget. People, it's not, you don't look crazy if you are trying to do something with blockchain. Now we see more business applications with actual people that are thinking, hold on, why do I have 700 versions of this container when it's always one thing? I just want to know the latest state. So whenever you feel that you have a system like that you have 700 kind of data points for the same thing, that you don't know what's the latest, usually it's a good sign that we should start decentralizing something and have a single point of truth. And now I see, like, the last year for sure, it's coming from the business side. It's the guy that is validating, it's the guy that is in charge of ordering, it's the guy that is actually looking at supply chain. And we talk to like very big names and very small names. Most of them have the same problem. Anyone that is actually losing money due to friction. So anything that is like slow to respond, to have versions, to frauds. So it's usually now the people that are actually, look, I come from a world, not just because I'm an Israeli, I'm kind of more kind of practical, right? So I either make money or save money. I don't believe in la la land. I like crypto, I can do theory, fine. Sometimes I can sit, over a weekend and talk like really like nice cryptographic models that are very theoretic. I like to see stuff in production. I like to see like, what are we doing with it, right? And it took a while, 2015 when I was talking about blockchain, people thought I'm crazy. 2016, they were sure I'm crazy. 2017, they became a bit crazy. Now we see, that this craze is happening, maybe not at the pace that you see in the tokens, but we do see people understanding that we can't continue to create more and more clones of the same thing without the permissioning, without the validation of this is a valid transaction, yes or no. Or just think about this new model, right? Just the fact that I know that stuff is not going to change and I don't need to keep the copy all the time, that's a lot. Think about like me keeping like 7 years of history that I can just distribute it and forget about it. So yeah, the long answer or the short answer is now we see the business side where you can save money, make money, people that don't want friction driving the blockchain. You need architects, you need technical people from all sides, but you also need the business guys to agree on sharing stuff, on the SLAs, on the payments, on the cost of the system, how to share it, where to host it, et cetera, et cetera. So yeah, it's almost like the full stack, to be honest.
All right, so we posted the Genesis block. Ordering services in.
So now, so we have the Genesis block. We have like the 2 channels. It's all done. You should see. By the way, Fabric is very, very verbose. So if you don't remove logs, it will tell you everything. Just don't worry about. Sometimes it's too much. Like I did it, but you can change the info level of the log. But it really tells you everything. I'm loading the configuration, and basically this is the output of create transaction. And now I'm doing an output of create transactions. So now I have 2 transactions in the system. Okay, the thing is, so far we haven't started anything. We just created configurations, and we loaded the configurations, and we basically set up an ordering service. And now we told everybody, hey, we have 2 channels. The next thing you want to do is actually to join the channels. So here is the nice thing about, so the question about Vagrant, I don't need Vagrant at all. I just wanted to have something consistent here. But effectively, if you are the guy who is running the system, you're going to do some Docker compose. And then we have a file here with all the stuff that we want to compose. And we just run the instances. This is me just saying Docker compose -f. This is the file with all the configuration of what I want to launch. And then this is like my kind of like Vagrant app. This is like Docker app. Okay? What's happening now? So I don't know how low level. I don't want to go too low level here because I want you to understand the big picture. If I'm going, I can go to. It will
You
take.
have 5 minutes.
Yeah. Okay. High level. 5 minutes. Okay. So what happens now, right? Basically, now I have different Docker containers that basically reloaded. Remember, it's the same image, different configurations. So now I have a P1, a P0 at org1, P0 at org1, and basically you can see that each of them is able to run like, let me show you, I just want to get into, so we have the peers running. Two things that people forget, it's all Docker. So Docker for me is like an operating system. I'm going to speed up a little bit. So I'm going to do Docker PS, which will actually show me all the Docker instances that are there. So now you will see that basically these are the image, and this is the container ID of anything that is running. So I'm having a Fabric tools that is running in the background. I have an image called Fabric Peer x86, that's the name of the image. This is the container ID. And I'm running an orderer, and I'm running a peer. So effectively, this is exactly what we saw before. I'm running 2 peers, 1 orderer, and some tools running in the background, okay? I can always run a status, and I can always check if anything is running. So again, so far, you don't touch blockchain, right? This is just Docker container running some stuff, and I just configured 3 files with the names of the ordering service, the names of the peers, and I just set them up. I can always create a new channel. So I can come in and say, hey guys, let's create a new channel. It looks like this, create channel, colleagues, and then now I created something colleagues, and now I have an endorser and orderer, and everybody was kind of endorsed. And so sorry, everybody is confirming that I have a new endorser and orderer that approved that that's what happened. This is the creation of the channel. And what else is interesting that you will see? If you see the following thing, it means that, so you cannot create the same channel twice, right? So I just put it for debug, right? So basically, if I'm trying to create colleagues again, it will just tell me, sorry, you know, basically, error authorizing update, error validating, da, da, da. Sometimes the errors are a bit weird, but yeah. Joining a channel, do I have 3 minutes, 2 minutes?
About 3.
3, thanks. So the next thing, so we created a channel, right? So we told the ordering service, hey, dude, we have like a few channels here. This is an isolation. And peers can join a channel. How do we join a channel? We just basically, these are all commands. So it's very easy for me to talk to the SDK and perform all this stuff, right? So the stuff that I'm doing is create channel. I can join a channel. And it looks like this. I can do a channel list, and I can look at the channels. I can say what channel I want to join. And basically, you see the 2 outputs. This is like what I see from every channel piece that's joined. And this is colleagues. And then this is channel list. And then I'm going to see the list of channels that we have at the moment. Okay? This is lab number 1. Very, very simple. Because we don't have a lot of time, I will show you lab number 2 very, very quickly. Sorry, don't get excited. So the next thing that is very important, I just want to show you very quickly, is, so I created a channel. So I configured a blockchain with, you know, with the Genesis blocks. I created channels. I have the configurations. It's all running. I have 2 channels now, one party and the other one for the colleagues. Then every participant that is already endorsed, or sorry, that enrolled, can join that channel. The next thing that is the most important thing is to propose transactions, right? So now I'm going to start moving stuff around. This is the stuff that I showed you, but I didn't show you like in practice, is the ability for me to sign a transaction and to get it accepted to the ledger so that everybody accepts that transaction and change the local records, right? So the transaction can be Jonathan pays Code $5, so Jonathan's balance is going to be Jonathan's balance minus 5, Code's balance is going to be Code plus 5. Okay, so this transaction basically has 2 kind of read-write set, right? Basically, I'm going to have like 2 attributes, values that are being changed, right? Like Jonathan's balance and the Code's balance, and that's going to be a transaction that I propose, right? So what you do with the SDK, you enroll and register, right, to join a network, get a T-set, or sorry, an E-set. You create channels if you want to, join channels when you want to, and then in the channel, you propose transactions that if they pass the endorsement, they will get written to the ledger. Last thing I want to say, every channel in a way has its own kind of ledger, right? So everything is in isolation. So whatever I'm writing to the channel that everybody in the channel can see, they can see it through that channel. So it's like a channel-specific ledger. It's a complete isolated solution. It's very difficult to go over all of Fabric, but this is the biggest change that you see that you don't see in Bitcoin or Ethereum. It's like the way to permission, isolate, enroll, propose, and understand who are your peers and what's in your network, so you can always know who are the validators.
Hey, a big question that comes up quite a bit is, are we really putting all that same data in all the nodes? Now, if you use channels, do we need to replicate the full node?
That's a very good question. So only the nodes that are part of the channel will get the next block that is shared with the channel. So if I'm a node that is only in the colleagues channel, or maybe if I'm a node that is in the colleagues but not in the party present, I will not get any updates regarding the party present. So I have no problem with compliance, regulations, exports. I will never see this stuff. So then you ask me, but why don't you run like 700 blockchains instead of having channels? That's a good question, right? So here's the answer. Because I have only one identity. So I have 20 participants, and I get one ESET, and I can still be a colleague and a party present chooser and a voter and an employee and an employer, whatever I want to do with only one ESET. So it's still very useful to have a big network. Okay? All right. So I just want to show you that like working with permission chains is actually not that difficult. Some people are afraid, but it's actually saves, in some use cases, it saves a lot of time. Yeah.
On behalf of Jonathan, myself, Kurt, and Paige, everybody, thanks for hanging in. We're going to be around for a little while. Really appreciate it. Big hand clap to each of you. Thank you.
Yep. Thank you, guys.
You want open? Do you want no? Because it's go ahead. Your question's probably going to be for John.
I can just answer the question. If you want to share that, I don't mind. I'm not in a rush, guys. I just came for this event for this. So, really.
Well, you have a question back here, Jonathan. I think it might be one for the room. Nobody feels obligated to stay.
Hi.
Hello.
Really interesting stuff about channels and all that. I'm wondering, from your cryptography and blockchain security perspective, what's your opinion on both the feasibility and security of off-chain state channels?
Mm-hmm. In Fabric or in general?
In general, or if it's possible on Fabric already, then yeah.
We have a solution that actually does state channels in a very interesting way. So what we have done, we created, so here's a nice thing. Let's say I have a document that I want to share, and I don't want to have it on chain. That's what you call an off-chain side channel. So we have a way to actually talk to the peer-to-peer network using the Gossip protocol. So, you know, like the Napster thing, right? I can just propose stuff and then it propagates around the network. So I can talk to another peer, agree with him on something, and let's say the easy case, we send each other a PDF via email, but how do we know that we agree on that PDF? Because now it's only me and you. You can say, hey, Jonathan, we never agreed on anything, right? So both of us calculate the hash of the PDF, and then we propose a transaction that is on-chain. That's nice, because now I didn't put the sensitive data on the chain. At the same time, you cannot repudiate. You cannot say, I didn't receive it. And later on, we can always show to a third party, hey, look at this. You have to make sure that you don't abuse this mechanism too much, because you're going to have a chain of garbage, and everything is going to be hashes all over the place. And then we don't even know if that's the only version we have. So that's the only downside, or that's the main downside. The minute I do stuff on-chain, off-chain that is not in sync, I can, look, I'm a crypto guy, right? I always find a path. So it's nice from time to time. If I need a side channel, let's do it. But I'm saying, look, if you want to collaborate, do the blockchain, you have to find, part of the journey is to find out what you really want to share. You know, and if you have some asymmetric things and maybe everybody knows and then you have something else, either open a channel or actually go to another blockchain or find another channel, like real channel. Call the guy. text him, email him. You know, like you don't have to put everything. I don't like it when people try to force everything on the blockchain as a solution that is looking for a problem, and then, oh, dude, we already promised the guy that, and then they start hacking. Let's take a step back. We can agree to disagree. We can reevaluate the solution. We can look at future features. Look, Windows didn't start at version 10.1. It takes time, right? So I think it's the same. We're all in the same journey. Yeah, so